Good evening, dear students. Okay, so today we are going to start with the next topic. So the next topic we are going to start with organic chemistry. Okay, so what do you mean by organic chemistry? Yes, so this is the first chapter. Okay, so this is your 12th chapter in your textbook, and the first chapter of organic chemistry, where you are learning the basics. Okay, basics of organic chemistry. Okay, so different techniques, different principles. Okay, so the basics, whatever we are going to study. Okay, the complete organic chemistry, because this organic chemistry, it will be continuation for your second year also. So for that, this is the base. Okay, so yes, anybody, what is organic chemistry? What is organic chemistry? Did in your colleges, did they complete with organic chemistry? Okay. So what do you mean by organic chemistry? So organic chemistry means what? We are dealing with carbon compounds. Okay. They are the natural compounds. So it is from where we are deriving it, or from where we are extracting this organic compounds from the natural sources. Okay. So what do you mean by the organic chemistry? Organic chemistry is nothing but they are made up of carbon compounds. Okay, carbon containing compounds are called as what? Organic chemistry, right? So in this organic chemistry, we are going to discuss different methods. Okay, when we are extracting any compound, okay, when we are extracting any new compound, so for that new compound, okay, so there will be some impurities. Okay, there will be some impurities present in that compound. So how we are going to remove that impurity? So there are different methods. Okay, there are different purification methods wherein we can remove the impurities. Okay, depending upon what type of compound you are purifying. Okay, what type of compound you are taking out. Okay, so there are different principles, there are different methods. Okay, so these are the different methods for purification. That is crystallization. Okay. Now, what is crystallization? So crystallization, here we are separating the compounds in the crystal form. Okay. So solution is there. So that solution, okay, after heating, then you are going to transfer it from through a funnel. Okay. And then whatever the compound you are going to get, that is nothing but, okay, the compound, the solution will it will convert, or it will turn into a crystal forms. Okay, so this is crystallization. So how this crystallization, how it depends, or how it varies. Okay, the compound and the impurities, okay, how they are getting separated, or how they are getting differed in their solubilities, depending upon the solubilities, okay, in the solvent. So in what type of solvent it is soluble, so that solvent we are taking, and then we are making the compound to dissolve in that. Okay, after that we are passing through a funnel. So whatever the impurities are there, that will be in the funnel, and the solvent, whatever you get, okay, with that solvent will be your compound. Now that compound, what will happen? That will convert into crystals, and your this what and your solvent will evaporate. Okay, I hope this you know. Okay, solvent will get evaporated. So this is about crystallization. So there are what is the okay process? Okay, that only. Choose a solvent, prepare a saturated solution at high temperature, filter. Okay, then you cool it, and then filter and dry the crystals. Okay, now what is the common or what is the example? Sugar and common salt. Okay, it can be purified with ethanol. Ethanol is a alcohol. So with that, you can purify. Next is a fractional crystallization. Okay, fractional crystallization means what? At different layers. Okay, at different layer, different mixtures are there. Okay, so fractional means at a different, these are there. Separate constituents are placed in separate layers. Okay, and you are doing crystallization. So that is called as fractional crystallization. So here also, what is the principle? The solubility of two substances, okay, in any solvent is slightly different than the slightly less soluble uh, substance crystallizes for. So depending upon the different substance, okay, in what the solvent is getting first soluble, that will first crystallize, and then whichever is the less soluble, then later it will crystallize out, okay. So at different layers, so different substances are kept, and through that you are going to pass the solvent. So the solvent which in which it is more soluble, it will first separate out, it will crystallize out, and then will be your less soluble part. Okay. Now how is this process? Okay. Prepare a solution of the mixture in a particular solvent, then allow to cool. Whatever the less soluble component is, that will crystallize first, and then what you have to do, you have to separate the various fractions. So at different fractions in different stages, your compound will get crystallized, so that you have to separate. Okay. So at different layers, whatever the fractions are there, that you have to repeat. So this is the fractional crystallization. Next is sublimation. Sublimation is a process where solid is directly converted into wafer. Okay, remember this. Sublimation is a process where solid is directly converted into wafer state, okay, or vice versa on cooling. So this is sublimation. So what we are doing in sublimation, whatever the solid is there, okay, in that we are going to convert into vapors, okay. And what if you cool these vapors, okay, if you cool these vapors, then again these vapors are converted back to solid. So this is the principle of sublimation. So what are the example of sublimation? You can take naphthalene balls, okay, naphthalene balls. So these naphthalene balls or your camphor, okay, camphor also. So these are do not convert into liquid. So from solid, they directly convert into vapor state. Okay, so these are the your this, okay, examples of the compounds of sublimation. Okay, next process is distillation. Distillation, in distillation, what we can purify? We can purify the liquids, impure liquids. Okay, so you can convert, what you can do, you can separate different liquids based on their boiling point. Okay, so whichever the lower boiling point liquid is there, first it will get purified, and then the liquid with the next boiling point. Okay, so the lower liquids will get purified fast, and then the liquid with the higher boiling point. Okay, so depending upon the nature of impurities and difference in boiling point, different types of distillations are present. So what are the different methods or different types of distillation? There is simple distillation, there is fractional distillation, and distillation under reduced pressure. So these are the different distillation. Okay. Steam distillation is there. Okay, fine. Then there is something called as solvent this extraction. Okay, solvent extraction. So these are the different methods. Okay, these are the different methods where you can purify the compound. Then there is something called as chromatography. Okay, chromatography, you might have heard about chromatography. So there are different types of methods further. Okay, so what is this chromatography? Chromatography is also a technique where you can purify the compounds, okay, for micro quantity, okay, for a smaller quantity. Now, what is the different type of, there is two types of this used in the chromatography. First is a stationary phase, another is the mobile phase, okay. So based on the different types of this, okay, phases, so stationary phase and the mobile phase, okay, you can see different types of chromatography are there. So there is adsorption chromatography, partition chromatography, okay, paper chromatography, column chromatography, thin layer chromatography, okay, gas liquid chromatography, okay. So these are the different chromatography depending upon the type of the stationary and the mobile phase. So depending upon the stationary and the mobile phase, stationary phase is a fixed phase, okay, and the mobile phase is a solvent. So it will run to that paper or the whatever the stationary phase you are taking. So it depends on what? It depends on the distribution of various constituent of mixture between these two phases. So there are different mixture, okay, a mixture of this will be there, that you have to plot on the stationary phase, and then you have to pass through the mobile phase. So depending upon the mobility of the constituent in the different spots, okay, it will go to the different this, okay. So this is the principle of your chromatography. So these are the different chromatography: adsorption chromatography, partition chromatography, okay. So I hope you have studied this in your theory. Okay, so I'll not go in detail. So please read these all types of chromatography. It will be helpful. Then next important factor is the qualitative elemental analysis. Okay, now we know that organic compound contains of carbon. Okay, organic compound contains of carbon. So along with carbon, there are different elements which are present. Okay, that is oxygen is there, hydrogen is there, sulfur is there, halogens are there, nitrogens are there, right? So these are the different elements which are present along with the carbon. Okay, now the how to detect or how to estimate the present of this elements. Okay, so this can be done by qualitative analysis. Okay, this can be estimated by qualitative uh, analysis. Okay, so these are the different reactions they have given. Okay, so how to detect the presence of carbon and hydrogen? So carbon and hydrogen, it can be detected by combustion with cupric oxide. So whatever the compound is given, if you react it with cupric oxide, what will happen? The carbon will convert into carbon dioxide, okay, and hydrogen will convert into water. So if carbon converts into carbon dioxide and hydrogen converts into water, this tells you the presence of carbon and hydrogen in that compound. So whatever the carbon dioxide is there, okay, that will turn your lime water milky. I hope you have seen this reaction, how to make the lime water milky. Okay, and water, what it will do, water will convert the white copper sulfate to blue copper sulfate. So if your given compound contains hydrogen, so whatever the white color copper sulfate is there, that will convert into blue color. So this confirms the presence of hydrogen. Okay, and if your lime water turns milky, this confirms the presence of carbon. So carbon is converted into carbon dioxide gas and hydrogen is converted into water. So there is a presence of hydration. So your copper sulfate, white color copper sulfate converts into what? It converts into a blue color copper sulfate. Okay, so this is the how to detect your carbon and hydrogen. Next is how to detect nitrogen, sulfur and halogens. So nitrogen, sulfur and halogen, it can be detected by a test called Lassigne's test. Okay, Lassigne's test. So what we are doing, whatever the different elements are that we are converted into ionic form. Okay, we are reacting it with a sodium metal. Okay, sodium is a highly reactive metal. So what we are taking in a fusion tube, we are taking sodium and we are going to add the compound. So after reacting the compound with the sodium, so if the sodium is if the sodium reacts with the carbon is present only in organic compound, and if the compound is having nitrogen, then it will give what? NaCN, that is sodium cyanide. Okay, and if the reaction if the sodium, okay, if the compound is containing sulfur, it forms sodium sulfide. Okay, and if the compound contains halogen, it forms sodium halide. Okay, halide can be anything: chlorine, bromine or iodine. So depending on this, we are converting into its ionic form. How? By reacting it with the sodium. Okay, now whatever the ionic compounds are there, okay, now that we are going to extract. Okay, we are going to do the Lassign state. We are going to heat that and we are going to filter, and whatever the filtrate we get, with that we are going to do the test, and that extract or that solution, whatever we extract, that is called as Lassign's extract. Okay, now how to detect the presence of nitrogen? Whatever the compound you are heated, okay, now you have to take 2 ml of that solution, the Lassign's extract. To that, you are going to add FeSO4. Okay, you are going to add ferrous sulfate. If the solution containing nitrogen, then it will convert into green PPT. Okay, it will convert green PPT. This green PPT, what you have to do, you have to boil and then cool. First boil it, and then what you have to do, then you have to cool the solution, test tube. And then what you have to do, you have to add H2SO4. Okay, that is sulfuric acid. Then what it will do, it will convert into green or Persian blue color. If it converts green or blue color, that means there is a presence of nitrogen. Okay, so this is the first test. Then if it consists of your, okay, now this NaCN. So these are the tests. Okay, these are the tests. Go through the test. So sodium cyanide, when it reacts with water, gives you NaOH. Okay, FeSO4 gives you green color PPT, that is ferrous hydroxide plus NaCN. Okay, now that if you react it with the sodium, okay, you get sodium ferrocyanide. Then sodium ferrocyanide, if you react it with again ferrous sulfate, okay, and if you add H2SO4, that is your sulfuric acid, you get ferric ferrocyanide, which, okay, if it turns blue or green color, that is Persian blue color. This is the color of the ferric ferrocyanide. Okay, so this is the positive test for sodium. Now, if there is a presence of sulfur, if there is a presence of sulfur, what you have to do? You have to take the same extract, sodium extract. To that you add lead acetate. So if there is sulfur present, then it will convert black PPT. It will convert into black PPT. So lead acetate, okay. Then the sodium extract gets you lead PPT. So the lead PPT, it is due to formation of lead sulfide. Okay, that is PBS. Then another test is there. If you react sodium extract plus sodium nitrochloride, okay, it will give you a deep violet color. So if deep violet color it gives, then there is a presence of sulfur. So this is another test. So please see the reactions. Reactions are very important. Okay, next is detection of halogen. So if the halogen is a chlorine, okay, then you get a white PPT. Okay, you get a white PPT. How? With reaction of silver nitrate. Silver nitrate, okay, you have to take the compound, okay, sodium extract. To that you add AgNO3, that is silver nitrate, you will get silver chloride. Okay, if there is a white PPT. Then if you have your bromine, okay, if the given compound contains bromine, then what I'm going to do, I'm going to add again silver nitrate. This will give you pale yellow PPT. If it converts pale yellow PPT, that means there is a presence of bromide. If there is iodide, okay, if there is iodide, then what will happen? It will be dark yellow PPT, okay. And this your AGI, okay, whatever the AGI is there, further whatever the PPT is formed, yellow PPT, that is insoluble in ammonium hydroxide, okay. And your this, if there is a chloride, okay, if there is chloride, okay, that is EG, white PPT is formed, then it will dissolve in ammonium hydroxide. And pale yellow PPT, that will sparingly dissolve, not completely dissolved in NaOH. Okay, so these are the different distinguishing tests of halides. Then if the given compound consists of phosphorus, okay, then take the organic compound, add sodium peroxide, okay, then extract with water, add aqueous solution plus concentrated HNO3 plus ammonium molybdate, gives you yellow PPT. So if you will get a dark yellow PPT. So if you get a dark yellow PPT, that means there is a presence of phosphorus. Okay. So the compound which is formed, okay, the yellow PPT, that is ammonium phosphomolybdate. Okay, remember these names, very important for CET exam. Okay, so they'll ask you the product name. Okay, so this was about the qualitative analysis. Quantitative analysis, okay, that is different elements present in any organic compound, okay, in how much quantity, right, in amount. So these are the different methods. So I'll just read out. I hope you have just go through them. Okay, these you have already discussed in the theory class. So that is how to estimate the presence of nitrogen. So there is a method called as Dumas method. Okay, please go through that Dumas method. Then one more method is there, Jaldal's method. Okay, there is Jaldal's method also. So these are the two methods for distinguishing the nitrogen. Okay, how to estimate or find the this, okay, determine the quantitative analysis, okay, of nitrogen. Then how to estimate halogen and sulfur. That is a Carius method. Okay, Carius method is there. Then phosphorus also can be estimated by Carius method. Okay, so go through these all methods. Fine. Then very important is your IUPAC nomenclature. Okay, then, next is IUPAC nomenclature. So these are the different suffix. Okay, just see the different suffix. Okay, so these are the different suffix. Okay, so let us see some of the questions now. Okay, so we have seen some synopsis. So remaining synopsis we'll see in the next class. Okay, so these are some of the different. So purification methods we have seen. We have seen the qualitative analysis and quantitative analysis. Okay, so let us see now the some of the questions. I hope you can see the screen now. Okay, so let us start with the questions. Okay, first question. Methoxy, methane, and ethanol are. Methoxy, methane, and ethanol are. So what is this methoxy, methane, and ethanol? Yes. So I'll write the structure of these. Okay, then you will come to know. So the options are A, functional isomers, B, optical isomers, C, position isomers, D, chain isomers. Okay, so this is about isomerism. So this question is based on isomerism. So let us see the question first. Okay, so methoxy methane. So how is the structure of methoxy methane? CH3O CH3. So this is a methoxy methane. Okay, methoxy. So this is a what? This is a ether. Okay, when RO R dash linkage is there, it is a ether. Right. Now ethanol. Ethanol is what? CH3, CH2, OH. Okay. Now here what you can see, what is the molecular formula in both the case? C2H6O. This is C2H6O. Right. You can see that the molecular formula is same. Right. What here you can see, there is a different, this is what? This is a alcohol. Right, this is a alcohol, ROH. This is a alcohol and this is a ether. So what you can see in both the case, that the compounds having same molecular formula but different functional group. Okay, so these such type of isomers, they are called as what? They are called as functional isomers. What they are called as? Functional isomers, right? So the compound, one more time I'll repeat. So the both the compounds, Okay, both the compounds, they are having what? Same molecular formula. Okay, they are having same molecular formula, but there is different functional groups. Okay, different functional groups are present. So because of that, they are termed as what? Functional isomers. Okay, they are termed as functional isomers. So in methoxymethane, there is a ether linkage, and in your alcohol, there is a OH group. Okay, that is a OH group. OH group means alcohol. This is a ether. So they are functional isomer of each other. Okay, so it is option number A. I hope this is clear. Okay. Next question. The IUPAC name for tertiary butyl iodide is. What is the IUPAC name for tertiary butyl iodide? A. 1-iodo 3-methyl propane. B. 2-iodo 2-methyl propane. C. 4-iodo butane. And D. 2-iodo butane. What is the IUPAC name for the tertiary butyl iodide? Yes, students, try to answer. Try to answer. I'll write the structure. Okay, it will help you. So see the structure. Tertiary means what? Carbon is attached to 3 other carbon atoms and it is a butyl group. So butyl means what? The total number of carbon atoms should be 4. So this is a 4, right? So this is a tertiary butyl group and there is a iodide. So this is the this. Okay, so this is a common name, tertiary butyl iodide. Tell me the IUPAC name, students. Try to tell. Yes, try. How to name this tertiary butyl iodide? Yes. How you are going to name it? How you are going to number it? Yes. Start numbering. So you have to, what is the first rule? You have to select the longest chain. Okay, Hema has answered at option number B. Okay. So first rule is what? Select the longest chain. Select the longest chain. So which is the longest chain? This or this? This, right? So 1, 2, 3. So this is our longest chain. Now what you have to do? You have to see the substituents. Now see the substituents. Okay. Now here, okay, one is the methyl, another is the iodo. Okay, one is the methyl, another is the iodo. Now you have to follow alphabetical order. Follow alphabetical order. Right? Follow alphabetical order. So which will come first? Which will come first? First will be your I. Right? So it will be 2-iodo, 2-iodo. Then at 2 position only you have methyl. Then how many carbon atoms? 1, 2, 3. So it is pro, right? And it is a saturated compound. So it is ane. So it is option number B. 2-iodo 2-methyl propane. So Hema has answered it correct. Very good. Okay, what about others? Others also please try. Okay, so these are the steps. So first you have to select the longest chain. Second, substituents. So when you are looking at the substituents, okay, then follow the alphabetical order. So which are the substituent? One is the methyl substituent, another is the iodo substituent. Okay, now which is the alphabetical order comes first, that is iodo. So iodo will have second position. Okay, 2-iodo, 2-methyl propane. So option number 2 is the correct answer. Okay, let us go for the next one. Which of the following species does not exert a resonance effect? Which of the following species that does not exert a resonance effect? Which of the following species does not exert a resonance effect? First one is your phenol. Second one is your chlorobenzene. Then C is your aniline. And third is your aniline ion. Right. Third is your aniline ion. Now here, which of the following species does not exert a resonance effect? Yes, this is a phenol. This is your chlorobenzene. This is your aniline. And this is your aniline ion. Right. Now, when we see this, okay, now here, when you see this, does not affect resonance effect. Okay. Now, resonance effect, how it is seen when a charge is, how the resonance, how we are going to do the resonance stabilize, there should be presence of some lone pairs, right? Now here, how do we get this aniline ion? Okay, just see, if I have a your this what aniline, okay, it will accept a proton. Okay, so lone pair of electrons are there on aniline. So this will accept a proton and it will form what? It will form a aniline ion. Okay, so it will form NH3 plus like this. Right. Now here, how this aniline ion is formed? It is formed by accepting a proton. By accepting what? By accepting a proton, the aniline ion is formed. Okay, now this is less resonance stability. Now this other, okay, now here, this is there. Okay, now your phenol, your aniline, there is lone pair of electrons, so directly it will undergo resonance. Right, chlorobenzene also. Okay, so that is resonance stabilized, so easily it will go, what? Resonance stabilized. What they have asked, which will do not exert resonance effect. So how it is forming aniline ion? So it will exert a positive charge. So there is a positive charge. Okay, how it is formed? Aniline ion by accepting a proton. So because of that, this is less stabilized. Okay, this is less resonance stabilized. Okay, this is less resonance stabilized. Okay, as compared to other aniline, chlorobenzene. Okay, so it is less resonance stabilized. Why? Because there is no absence of lone pair. Okay, there is no absence of lone pair, and if there are lone pair of electron, they can easily undergo resonance. Why? There is a double bond. This will be present, right? There will be a double bond of the benzene is present. So it will easily, so the other three, it will undergo what? It will undergo resonance. Why? There is a presence of lone pair and it can double bond is present, okay, of the benzene. So easily there is a resonance stabilized because of the presence of lone pair. Here it is already forming a ion by accepting a proton. So because of this, it is less resonance stabilized. Okay, and there is absence of the lone pair of electron, which is not in conjugation with the double bond. So because of that, it will not exert a resonance effect. Okay, so option number, which is the answer? Option number D. Option number D. Yes, Hema has answered it. Very good. Okay, so let us see the next one. The chemical name of anisole is. What is the chemical name of anisole? Anybody knows what is the chemical name of anisole? How is the structure of anisole? So let me show the structure of anisole first. Benzene with one O and CH3. Yes. So this is the structure of anisole. Okay. So this is a methoxy group. So let us write what is the chemical name. So methoxy and this is benzene. So it is methoxybenzene. Okay. So option number D. Option number D. So what is the answer? Option number D. So the chemical name of anisole is what? Methoxybenzene. Okay. Fine. Let us go for the next one. IUPAC name of this compound. IUPAC name of this compound. So let me illustrate it. So CH3, CH3, CH3 and Cl. Yes. What is the chemical name? Again, follow the parent chain, longest parent chain, then the substituents. Yes. How we are going to see? So this is 1, 2, 3. Here only 1, 2 are there. Okay. Then at 2 position, you have fluoro group. So 2 chloro, 2 methyl, 2-chloro, 2-methyl, then what? Propane, right? So again, option number 2. Option number 2 is the answer. Okay. Let us go for the next one. Understood? Understood this? How to give the IUPAC name? So first select the longest chain, then see for the substituent. Okay. Then which if the substituents follow the alphabetical order. Okay. Chloro will come first, then methane will come. And then you see the number of carbon atoms are 3. So prop and there is a saturation. So it is ANE. Okay. So option number B is the correct answer. Next question. Chloroacetic acid is a stronger acid than acetic acid. This can be explained using. So chloroacetic acid, okay, acetic acid is CH3COOH. Chloroacetic acid means what? CH3COOO. Okay, one of the, this is replaced. So it will be CH2Cl. Okay, so one of the this is a chloroacetic acid. So how chloroacetic acid is stronger than acetic acid? What is the, this, yes, which theory can be used here? Chloroacetic acid and acetic acid. Now this is CH3. CH3COO, or I'll write it as C double bond OH. Okay. And your chloroacetic acid is CHHCl, then C double bond OH. Okay. How it can be explained? By which concept? Yes, it can be explained using inductive effect, right? It can be explained using inductive effect. Now here, there is a hydrogens are present. Okay. As compared to hydrogen, your chlorine is there. Chlorine is a highly electronegative group. So what it will do? It will tend to pull the electron towards itself, right? Chlorine, when you see the electronegativity of chlorine as compared to oxygen, okay, chlorine is highly electronegative. So what it will do? It will tend to pull the electron towards oxygen, and there will be partial negative charge. This will be partial positive charge. This will be partial positive charge. Okay. So your this is on carbon. Okay, not on oxygen. So partial positive charge. So like this, the charge is transferred to chlorine. So because of this, okay, your chloroacetic acid is more acidic than your acetic acid due to minus I effect. It is called as minus I effect or the inductive effect. Okay, minus I because there is a the chlorine atom, which is a highly electronegative atom. So what it is doing, it is pulling the electron towards itself, right? So because of that, it is called as a minus I effect. So it is option number B. Okay, it is option number B. So as chlorine is a highly electronegative atom, so element, so what it is doing, it is tending to pull the electron towards itself. So as a result, there is a partial negative charge on chlorine, and on carbon, there is a partial positive charge because the electrons are moving towards the chlorine. So this can be explained by using minus I effect. So option number B is the answer. Okay, fine. Next question, the IUPAC name of the. So another, so from this organics chapter, okay, IUPAC are asked, very important. So you have to practice the IUPAC names. Okay, fine. Now, how you are going to use the rule? Yes. How you are going to, if you do not understand like this, these open are called as the methyl groups. Okay, these are the methyl groups. And how you are going to see now, CH3, then is your CH, CHO. Okay, next is your CH, Br, then is your CH2, then is your CH3. So these open ends are CH3. Okay, here it is CH, this is CH2. Fine. Now, let us write how we are going to explain, how we are going to number this now. You have to select the highest this, right? So if I write it from here, okay, if I write it from here, so 1, 2, 3, 4, and 5. Okay. So if I write like this, or okay, there is a this, right? So this, if I take 1, 2, because I'm going to consider the pentanol also, right? Yes. So I should consider the aldehyde group. Okay, I should consider the aldehyde group. So I should number it from here. So 1, 2, 3, 4, 5. Now, which are the substituents now? Which are the substituents? So this is a parent chain. Okay, so a parent chain I am going to consider as the this your aldehyde, right? CHO is a aldehyde. Okay, what is the suffix? It is al. Okay, it is al. Al is the suffix. Now, between which are the this which are the substituent? One is methyl, one is bromo. So between bromo and methyl, bromo will come. Right. So it is 2, 3 bromo, then 2 methyl, then pent, because it is 5, pent, 10, pentane, and al, al. Okay, pentanal. So which is the answer? It is option number 3 bromo, 2 methyl, pentanal. So option number D. Option number D. Okay, understood? So here we are considering aldehyde as the parent. Okay, we have this is our parent chain. Then these are the substituent. Substituents, we are following the alphabetical order, and then suffix is the al. Okay, al. Fine. Let us go for the next one. Which one of the nitrogen atoms in this is most nucleophilic? A, third one, B, first one, C, second one, and D, all three nitrogen atoms are equally strong nucleophilic centers. So let me write the structure. This is the structure NH2, NH2, NH, C double bond O, NH2. So which is the most nucleophilic here? They have asked first one, second one, or third one. Yes, try. Option B. Okay, Hima is answered as option B, first one. Now, which is the here your this is there, right? Your oxygen is present. Now, when you see the oxygen, okay, which is most nucleophilic. So the first, it is the first which is the most nucleophilic. Okay, why? Because it is far from this nucleophilic carbon. Okay, it is far from this carbonyl carbon. Okay, and these remaining nitrogen, they are nearer to this carbonyl carbon. Okay, so they can easily they will easily what you call, they easily undergo resonance. Okay, they will easily form resonance with them. Okay, they will undergo resonance quickly with this carbonyl carbon. So because of this nitrogen which is far away from this carbonyl carbon, so this nitrogen, the first nitrogen is uh, most nucleophilic. Okay, because the other two, second and third one, they are nearer to carbonyl carbon and they may undergo resonance. Okay. Next compound, tell me the IUPAC name. Next compound, tell me the IUPAC name. Try to answer. Yes. Let me write the structure. So if I want to illustrate this structure, how it is? Yes. So how many carbons are there? No, this is not a carbon. So you have to start from this. So if I want to write this, so it will be CH double bond CH, CH2, CH2, CH, CH2, then C double bond O, OH. Okay. So the carbon will be 1, 2, 3, and 4. Okay. The numbering will be 1, 2, 3, and 4. So what is the numbering? How we are going to name it? Try. So the name will be, what is the name? Bute, 4 carbon. So bute. Then at third position, you have alkene. Okay, when you have alkene, the ending is in, En. Okay, in. Then what you have? You have a oic acid. Okay, because it is a carboxylic acid, the ending is oic acid. Okay, it is a oic acid. So it is bute 3 in oic acid. So option number A. Option number A is the answer. So the IUPAC name for this given compound is bute 3 in oic acid. Okay, fine. So option number A is the answer. Let us go for the next one. Which one of the following is not true regarding the electromeric effect? Now, what do you mean by electromeric effect? Yes, Hima had answered the last answer correct. Very good. Yes, electromeric effect is what? It is a, which of the following is not true regarding electromeric effect? A, it results in the appearance of partial charges on the carbon atoms. B, it is a temporary effect. C, it operates on multiple bonds. And D, it requires an attacking reagent. Okay. So what is an electromeric effect? Electromeric effect, what it involves? Yes, anybody?
Transfer of electrons of multiple bonds, one of the bonded atom.
Yes, very good. Okay. So okay, so yes, very good. So that is a complete transfer of electrons, right? So the effect involves the complete transfer of your shared pair of electrons, okay, to the one of the atom which is joined by multiple bond, okay, which is there is a requirement of a attacking reagent also. So this is called as the your what electromagnetic effect, and this effect is a temporary effect. Okay, so option B is correct. Okay, so this is also true regarding our electromagnetic effect. It operates on multiple bond. This is also true. It requires an attacking reagent. This is also true. Okay, so which is not our answer, okay, or which is not true regarding electromagnetic effect is it results in the partial appearance of partial charges. This appears in the inductive effect. So the partial charges, right? The partial charges, formation of partial charges, it forms in what? Your inductive effect. Okay. So option number A. So this is not true regarding the electromagnetic effect. Yes. So option number A is the answer. Let us go for the next one. So this is a compound. Tell me the IUPAC name. So tell me the compound. Yes. What is the IUPAC name of this compound? Yes. So if I write it, so it will be CH3, CHOH, CH2, C double bond O, and CH3. Okay, so when we are numbering, it will be 1, 2, 3, 4, 5. So which is the this? So this is our this. So it is 4 hydroxy, right? 4 hydroxy. Then at 2 you have a ketone. So it is one. Okay, when you write ketone, what is our suffix? It is ketone, right? One. So 2O2. Okay, then this is our parent chain, right? So we are calculating the ketone also. So how it will be? So 5 number. So it is pentanone. So it is option number A. Option number A, because we are taking the parent, in parent chain we have ketone. So it is what? Pentane on. Okay, so option number A. Option number A is the answer. Yes, Hema has answered it correct. Very good. Okay, let us go for the, I hope you are understanding this. Okay, let us go for the next one. Next question is, acetone and propanol are what? What are acetone and propanol? Write the structure and see. Acetone and propanol are what? Acetone is CH3, C double bond O, CH3. So this is your acetone. And what is propanol? Propanol is CH3, CH2, C double bond O, H. Right. So this is propanol. Propanol. Okay, this is a aldehyde. This is a ketone. Count the number of carbon atoms. So this is C2, H6, no, C3, C3H6O. This is C3H6O. So again, this is what? It is a functional isomers, right? Same structural, same molecular formula, but different functional groups. Different functional groups, right? In one you have a acetone, ketone, another you have a aldehyde. So it is a functional isomer. Option number A. Yes, Hima has answered it correct. Very good. Okay. Let us go for the next one. This we will see next time. Okay. One more IUPAC name. This question we'll see. IUPAC name. IUPAC name. Okay. See here. CH3. H. Br. H. H. Okay. So how we are going to number this now? So this is the longest carbon atom. This is the longest carbon atom. So what we have taken parent chain. ene. Okay, that is a alkene. So this you have 1 bromo. Then what you have? Bute. Then at second position, bute, which you have at second position, you have ene. So it is option number A. 1 bromo, bute, 2 ene. 1 bromo, bute, 2 ene. Okay, 1 bromo, bute, 2 ene. So if you want, I'll write the structure like this. So CH3, I'll rub it, okay? I'll write it properly here. So CH3, then CH double bond, CH, then CH2Br. Okay, so this is the structure. So we have named it 1, 2, 3, and 4. Then what it is? 1 bromo. Then at second position, you have so 1 bromo. Then what is the parent chain? The parent chain is bute. Okay, so bute. So it is bute, then 2ene. So option number A is the answer. Understood? Yes. So these were some of the questions for today. Okay. So remaining questions we'll be discussing in the next class. Any doubts up to here? Yes. Any doubts up to here? So few more questions are there. Okay. So that we will discuss in the next class. Okay. Fine. So no doubts. Okay. So we will end the session here. Okay. We'll meet in the next week. Thank you.